the half mile racing is just like a bragging rights of who's got the highest speed at the end of it, when drag racing is who's beating you to the end.
Welcome along to another episode of the HPA Tuned In podcast. Now, on the podcast this time, we have Myles Kerr from English Racing. Myles is a build consultant in English Racing. We'll find out as we talk to Myles what that term actually means, but he's probably best known for his green DC2 Honda Integra that he uses for both half mile and quarter mile racing. Probably getting up there as one of the more powerful B-Series engines around, currently making around 1400 wheel horsepower at about 70 PSI of boost. So safe to say it's no slouch. We go into a lot of detail with Myles in particular around the reliability of these engines. We talk about the 4B11 as well, and some of the aspects of sleeving technology and also head gasket integrity, which I know from my history in drag racing becomes a real limiting factor with high boost turbocharged engines. Tim, what did you reckon of that interview? What did you take away from it?
Yeah, we certainly covered a lot of ground there, but one of the things I found really interesting was them talking about some of their tuning strategies to limit the amount of traction control intervention they need to use, which was, quite interesting to me, just actually, coming from the side of more preventing the traction problem in the first place and not having to sort of rely too much on those electronic aids.
Yeah, I think it does obviously depend on the engine, and we could probably lean pretty heavily on traction control in engines that aren't making very high specific power levels. But as we'll talk about in the podcast, as those power levels climb, we do get to a situation where the traction control can actually end up doing damage to engine components. So
sure.
Something that I think a lot of people may overlook.
Definitely.
Before we jump into the podcast, just wanted to discuss one of our Instagrams over on the HPA 101 Instagram. If you aren't following us, please make sure you do. We post some pretty interesting content all the time, and always interested to see our comments on that. This one was a photo that we took when we were at PRI a few years back, and it's of a piston that's been created using 3D printing, additive manufacturing, and generative design. And it got a lot of engagement, particularly a lot of people saying that they wouldn't trust that piston as far as they could kick it, and it doesn't look safe. Tim, from your background, you know a little bit about 3D printing and additive manufacturing. You're a mechanical engineer. How does this technology really pan out? Can we trust it?
Yeah, there's a couple of things here. One is the design process, and the second is the manufacturing. So the first part, the design, is probably the most interesting part of this, where essentially what you're doing is giving the computer a set of constraints. You say, I want this part to be this big. You say, these features are the parts that are important to me. We cannot modify these features, but this bounding box or this area of the part, you can do whatever you want, and these are the forces that it's going to be subjected to. And essentially, it's giving you the ideal mechanical design to be. Usually, you want to minimize mass. You might want to minimize things like inertia, depending on what the part is. And you say, these are the constraints. Show me what the optimum is, and this is the outcome of that. And as long as your constraints are good, then theoretically this should work. But it's garbage in, garbage out. Same old story.
Yeah, absolutely. There's no magic here, and I think as well, it's really hard to get a solid read on this. The information for the current crop of F1 cars is very sketchy, so I take it with a grain of salt. But there was an article that Ferrari were using additive manufacturing for the pistons in their engines. Obviously, with those engines, the cylinder pressures are immense, and anything they can do to get a gain in terms of weight versus strength is obviously key.
For sure. And I mean, additive manufacturing is just one of those technologies that's really just accelerated so quickly over the particularly in the last 10 years. 10 years ago, we were using it a lot for prototyping, more for just understanding how things were going to fit together in a real situation. Whereas now, building functional components and even highly stressed components like this is becoming much, much more practical. So I've got no doubt there's some people out there doing some really interesting stuff with it.
Yeah, I think it's fair to say that this technology is, while it's developed, is still probably in its infancy. So it's really interesting to see what's going to come of this over the next 5 to 10 years. No doubt it's going to have a bigger influence on what we're doing. Now, before we jump into the podcast as well, we've just talked about pistons there. So for those of you who are interested in engine building, just understand that at HPA, we do offer a full suite of engine building courses, perfect for those of you who want to learn a little bit more about the fundamentals or the practical aspects of building engines. And as part of that, you can use the coupon code podcast75 at checkout. That's going to give you $75 off the purchase of your first course. Alrighty, let's bring in our guest. Well, welcome to the podcast to Myles. And Myles, thanks for joining us. Could you maybe give people who haven't heard of you and your Integra a real quick rundown on what you do and what your Integra is?
Yeah, so my name is Myles Kerr. I work for English Racing here in Camas, Washington, and I've been here just 10 years, about a month ago. And I bought the Integra 100% stock in 2006, and literally every nut and bolt on the car I've touched at one point, all the way up to now it's a all-wheel drive 1400 horsepower car. So I mean, it's been 213 and a half miles so far. It's trapped 183 and a quarter miles so far, and I mean, I drive it to Starbucks, I drive it around. It's kind of one of those stupid things that you shouldn't drive on the street, but I've got to push those limits, and that's what I do. So
I see from your Instagram stories you spend probably about as much time at Starbucks as you do in English racing in the shop.
I would say it's a pretty comparable there for sure.
All right, so let's just start by talking just briefly about what you actually do at English Racing. And I wasn't too sure. You're sort of customer service, but you actually called yourself a build consultant.
I think that's, yeah, I think if you call English Racing, I'm going to be the first one that picks up the phone. So kind of your first point of contact, the first person you see when you walk in the shop. And I mean, I know everything from how to build a car, what it takes to build an Evo, a Supra, a GTR, kind of any combo really, all the way up to, I mean, we've got cars that are making 2,600 horsepower now. So, you call us with a dream, or just you want your car aligned or an oil change done, I can set up the schedule. Or if you say, no, I'm really serious, I want to go race my car, then I ask how serious they are about really racing their car. Are you ready for all the breakage? Are you ready for all this stuff? And
what you're meaning is how deep is the wallet?
How deep is the wallet? Yeah. How fast do you want to go? And do you are you ready for the breakage? Are you ready to sit in a line for 4 hours at TX2K because 10 people oiled down the track, and are you ready for that? And you really find out real quick how serious someone is or not. And that's, I'm not going to say that I turn everyone down or I turn everyone away, but the people who are truly serious, they're going to get into it, and the people who are just like, I think I just want a 500 horsepower car. How do I get there? Cool. I can help you with that too. And these days anyone can find information online, and a lot of people can purchase parts from pretty much anywhere. The way we work at it is if you're coming to me and you're coming to us for our service and who we are, I'm going to give you that guarantee that this car is going to make X power. But I'm not going to give you that parts list ahead of time so that you can just go purchase it from everywhere else, because, we're in a business for service / tuning and building, not really a parts sales place like, certain other companies that just sell parts, So we know what it takes with pretty much any Evo 8, 9, 10, a Supra, a GTR, and even a Honda now, what it takes to make X power. And we're just not going to give you that shopping list until at least we've got a deposit down of getting going on a build. So I think that may be the easiest way to explain kind of what I do.
I think it's a situation that's become so prevalent. I mean, I saw it during my own business as well, STM, and you'd have customers that obviously, and I understand they want to save $1.
Correct. Yes.
But that parts list shopping, like, okay, give me your 10 years of experience. What parts do I need on this car to do the job? Yeah, great. Exactly. Thanks for that. Now I'm going to go and get those cheaper off Amazon or eBay.
And then I'm going to go back to you and have you install them all. and then I'm going to be butthurt when it doesn't make the same power that you told me it would make.
Yeah. No,
Yeah,
it's
100%.
a weird situation that we see over and over again in the industry. And I think
And
people do need to appreciate that the reason you can guarantee a number is because you have that 10 years of experience developing, and all of that takes time and it takes money. And that's really what you're paying for, not the probably 10% markup on some of the parts anyway. You're not probably getting rich on selling a wastegate or a blow-off valve.
We're not. I mean, really the majority of the margin is in our labor and our service and our tuning. The part sales are really just, I mean, let's call it realistic, 10 to 15% on the majority of the parts out there, unless you're manufacturing something yourself. You make your own parts, like ETS, Extreme Turbo Systems, like decent margins for like building certain things, and then certain margins, they're really low because they have to be competitive in certain areas. So with us, our motors are not the cheapest out there. They're probably the most expensive, but you're going to get our years of experience to guarantee that it's going to do exactly what we say it's going to do.
Yeah, I think there's a saying out there: when you pay good money for a part, or an engine for this case, you only have to cry once.
You only cry once. And the amount of people of cars that are in the back parking lot, I think we have like 47 cars here right now. I would say 5 cars out there have paid twice now.
Yeah.
That sounds like a relatively lower percentage than I was expecting.
Well,
I mean, it's hard to learn those lessons.
I can think of 5 names right offhand that I know for sure are in it a second time, but there's probably more out there that have gone through a couple scenarios of paying. I mean, I've got one car out there that came to us last year with an 800 horsepower Gold and an Evo 10. And, people think Evo 10s, they make power, but they don't stay together very well. Between the narrow rod bearings they have and head gasket issues if the sleeves aren't done correctly. I mean, there's a lot of things into an Evo 10 that not a lot of people, they're like, oh, we built 4G63s, we know how to do this. Well, you do to an extent, but they are very different engines at 800 and above. And so I had this customer come in. He's like, he had called us a year prior and spoke to one of the other gentlemen who worked here before. And he was like, why do you want to build an 800 horse Evo 10? Are you sure you want to do that? And he got a very bad vibe from him. And so what ended up happening was he went somewhere else that made him feel all warm and fuzzy about this 800 horse build. And it spun the main line on the dyno while it was making 710 wheel. And so he had just went through the entire build process there. And here he is doing one of our first custom 2.2 liter strokers we did in the Evo 10, where we took a Manley crank, ground some stroke out of it, did the wider bearing that we do in the drag car, in the drag 10. And so it's kind of best of both worlds that we feel, because they're kind of laggy when they're a 2 liter, And so we've got this custom one. He's the first one that's got it. And, it's a really expensive motor, because you're taking a $1,500 crank, then you're putting another $1,000 at this company that takes the stroke out of the crank, and they grind the bear, So yeah, it's almost $3,000 in a crank that we could have had maybe someone do a crank for us at one point. So, it's a pretty expensive motor. And so it's just in the process now. We just installed the Motec on it. But yeah, it took a year to get all these custom parts done for this car. And here, this guy, yeah.
I don't think people maybe appreciate how much time and the money goes into some of these custom parts. A little off topic, but seeing as you've brought it up, obviously the 4B11, the natural sort of younger brother, I guess, to the 4G63, which we all know and love, and technically, arguably a superior engine. Certainly, they seem to make more power, arguably, for the same turbo and boost pressure. But you've gone from a cast iron block to an alloy block, and you've sort of just insinuated there's a couple of problems. Obviously, with alloy blocks at that sort of power level, very high power level sleeving, which is something I really wanted to talk about anyway. So maybe we'll get to that a bit earlier than I'd expected. And you've talked about these narrow rod bearings. Now, that's something that a lot of people don't really appreciate it as a potential limiting factor / failure point. So can you talk us through what you mean by a narrow rod bearing and why that is a problem?
Yeah. So, I mean, I look at it like a sharp point versus a dull point, trying to stick a knife into someone. There's more surface area on the wider bearing, and it's more, I guess you maybe call it crush for more area to
It's like a surface pressure thing.
surface pressure thing. Yeah. So we've got more bearing, we've got more oil, more rod, more everything that on the narrow bearings you don't have. And I mean, we went through motor after motor in the beginning. Really, it got to the point on our drag car when we got to like, over 1,000 horsepower. I would say we were going through rod bearings, I would say probably over 10 passes going through stuff. And then we actually, what happened too is we bent a rod. We bent an R&R rod, like, probably like a 15-degree angle. And we were like, so, we call GRP because we switched to GRP, and we're like, hey, we need to build a, he's like, oh, what happened? We're like, oh, we bent the rod, but like the engine was fine. Like there was no failure point. Like nothing happened. It just, in
so
our
you got away with it.
Power. Yeah, we got away with it. Didn't find its way through the block. And so we get a hold of them, and we're like, he's like, oh yeah, they call it a window. It's got a windowed aluminum rod, not a solid beam.
Right.
And so, he's like, you need a solid beam. All right, cool. Can you make that? He's like, no. I'm like, well, what do you mean? He's like, well, for one, there's not enough clamp for the bigger rod bolt that they're going to need with the smaller bearing, and the more weight they're going to add to the more weight they're going to add to the rod itself. So I'm like, so what do we need to do? He's like, you need to cut the journal down on the rod so that we can put a smaller bearing in it as far as diameter, and also it's a smaller journal in diameter and a wider bearing.
So just getting that wider bearing. So
yeah,
the increase in surface area. So that's sort of
correct.
The trick or secret to getting the 4B11s to be reliable at that sort of power level.
It was one of the things we noticed. Yeah, I mean, and we don't ever have bearing failures anymore. There's not a oh well, we ran out. We smoked a bearing. We don't go through that anymore. We've gotten that part situated. We don't bend rods. We don't go through that. And now at our level at the Evo 10, valve head gaskets were a problem because we used to just do a step deck block. And then that became, now we have our own custom stuff we do, kind of like similar to what's in the Integra.
Let's just leave the head gasket off to one side, because that's
sure
one of my personal pet peeves. I've done more than my fair share of leaking head gaskets in 4G63s, but that's like a really a key part for these high boost engines keeping them together. So we'll come back and talk about that separately. But just while we're on the rods, so I remember at I think it was Pikes Peak Airstrip Attack, and I was speaking to JR from ETS about their GTR drag car. Half mile car, and I think there's just the stuff that people don't understand. I think at the time that was circa 3,000 wheel horsepower, and he was telling me that basically the best of the best crankshaft, I may be mistaken,
passes.
10 passes, but that was the best crankshaft money can buy, and 10 passes, throw it in the bin at maybe $4,000, $5,000, $6,000. I'm not even quite sure, probably more than that actually.
One of the things on that is I don't think we've ever, even us now, and I think they go in the cars, they make the power, and they're cracked already, but they just stay together. I've never seen one break into one of the Bryant cranks, that they use. I've never seen one break into, but if you Magnaflux it, it's got a crack every single time.
That's the problem with any of those parts, though. As soon as you do that Magnaflux test and crack testing, it's got a crack. We've had the same with gear sets. It probably cracked, like you say, maybe the burnout or the first pass, but
who knows? Or on the dyno when it makes 2,000. But
how long is it going to hold together?
Exactly. So that's one of those things is you're like, am I really going to put this $50,000, $60,000 motor together with a $5,000 crank that I could just put a new one in? So, ETS has literally probably a room full of these cranks that are just nothing, and I've seen the room and I've seen the amount of, we have the same amount for 4B11 stuff, but they have a lot of GRP, Carrillo rods and a lot of Bryant cranks.
It's an expensive car part symmetry. I think if I came back to my own Evo drag racing days with the earlier 4G63, the Evo 1 to 3 spec, and we were using billet cranks, and we would spend $4,000 on a billet crank and pull it out after half a season for a freshen up, crack test it, the thing was cracked.
Yep.
We ended up resorting to the factory crankshaft because
Yep.
they would also crack, but we're paying, I can't even remember
Like
now, 1,000,
$500.
yeah,
Yeah.
$1,000 maybe for a crank.
Cheap.
Yeah, so people sort of, I don't think they appreciate just how good those factory components are, being that they are forged from the factory. They're a quality item, and I certainly never had one actually fall to pieces. I just wanted to quickly come back because we sort of touched on that VR38 and the ETS car, but I think one of the things that sort of a factor there, and it really talks into the story that you've got here about the rod bearing on those V6s, particularly the crankshaft journals for the rods. You don't have that luxury of being able to make them wider, so that's a sort of inherent flaw at that sort of power level with the VR38.
Yeah, so I think ETS actually does a big block Chevy rod journal on those.
Okay,
so I don't know if they widen them or what they do, but ETS did it back in the day. I think because they said the availability of the parts would be a lot easier for the big block Chevy rod journals.
Yeah,
and in the end, it sounds like it was also probably a strength thing too.
Gotcha.
And now every crank you buy from pretty much any manufacturer, T1, AMS, they all have the same recipe, big block Chevy rod journals in them now.
Yeah, everyone sort of stumbled upon the same solution to this problem.
There were people making fun of ETS about their Chevy rod journal crank back in the day, like when they first did it, and it's kind of one of the industry standards now in the GTR that all of them do that. So I would say that ETS did a lot of stuff in the beginning that like it was like thinking like, oh, this is a really dumb idea, but it they got bit at one point with like they had the cable throttle bodies with a car that's a drive-by-wire car, and they have the throttle bodies hidden with nothing, just being ghosted basically. So they've done stuff like that most people were like, it's a bad idea. But when you're having throttle body problems shutting you down 130 feet out of the quarter mile and you're about to have a record pass and you keep getting shut down, GR was really good about like, well, we're going to do this even though we know it can cause problems because you don't have any torque reduction without throttle. So he's gone through a fair amount of stuff to get there, but I think that car still has cable throttle bodies on it till today.
Yeah, I remember seeing that as well. Mm-hmm. All right, we'll get back to English racing stuff, and particularly your Integra. A little bit of a sidetrack there for the GTR stuff, but it sort of also talks to another point that I want to discuss, which was reliability for these high horsepower cars. And I think the sort of numbers you're talking, your 1400 wheel and the GTRs as well, 2.5, 3,000 wheel. People hear these sort of numbers thrown about relatively frequently now, and it sort of becomes a bit of a new norm, and people sort of think, well, I can make 1,400 wheel horsepower out of my B18C and it'll do 100,000 miles between freshen ups. The reality though, somewhat different. Can you give us a bit of perspective on that? What do people really need to know?
I would say I'm kind of lucky right now. The motor that's currently in my car is on its third season right now. So I've almost say I'd probably on the opposite side that I would expect it to be. I pretty much expect it to go at any time at this power level. Now that it's putting more power down in second, third, and fourth being all-wheel drive, before it'd be like let's call it a 1,250, 1,300 horsepower at the very top of the RPM. So it's like a very soft 1,300 horsepower. Well, now I've changed the boost control strategy to where it's a very hard 1,300 horsepower. So it's like as soon as it can make full boost, it makes full boost, and it's harder on it. So I fully expect it to not survive as long as it has been. But yeah, I mean, at this power level, how hard are you on it? Are you doing half mile? Are you doing quarter mile? Because I think there's a difference between both of those.
Definitely.
I would say the half mile is harder on the engines. The drag racing's harder on the hard parts like transmissions, axles, rear differentials. So the half mile, it's still an acceleration game, but it's not as much of an ET game. So
it's not so critical. Your terminal speed through the traps at the end of a half mile is not as driven by how hard you get out of the hole. Basically, that's what you're saying. You don't have to launch the thing at 10 tenths like you would in a quarter mile.
Correct. Yeah, you don't have to launch it. Launching it does get it some mile an hour, like probably 2 to 3 miles an hour versus rolling out versus launching it, at least in my car, because it's pretty laggy. I don't have like any boost till like, let's call it 6,000 RPM, 6,500, right? So if I roll out in Colorado, it was worth 3 miles an hour versus launching it at 6,000 RPMs and just letting it ride the traction control in first gear.
As someone who doesn't come from this sort of world of drag racing or half mile racing, could you just explain exactly the difference in that format?
So drag racing, quarter mile, it's all about who gets to the finish line first. So you have a reaction time off the line, and then who crosses the finish line first is who wins. Well, in the half mile racing that we do, it's who has the highest speed at the end of the track, at the end of the half mile, that wins the race. And you could be side by side with someone, and yeah, everyone wants to beat the other person. You want to beat the guy next to you, but you also want to be faster than him on the other end. So the half mile racing is just like a bragging rights of who's got the highest speed at the end of it, when drag racing is who's beating you to the end.
Got you.
And those are probably the two fundamental differences. The other thing is half mile racing is all done on like airstrips, like airports. So it's no prep. When drag racing that you're doing most of the time is fully prepped drag strip, rubber on the ground. You're racing on slicks of some sort. And the traction you can put down in first, second gear versus the half mile, it's a huge difference, like a drastic difference.
Does this make I know we're not going to get into chassis setup or anything like that today, but you have to be a bit more versatile. You're having to, if you're going to these different surfaces and stuff you're talking about airports or airstrips, like
mentality maybe for a no prep.
Totally. Strip. Like maybe it's more variable as far as setting the car up and stuff.
It's harder to put power down on it's basically just like the street. It's concrete, basically. Mm-hmm. It's grooved concrete. So and that's what you're putting the power down. To put it into perspective, my car on the track last year trapped almost 183 in the quarter mile. And when I ran 213, it only trapped 160 in the quarter mile. Yep. So I'm losing 22 or 3 miles an hour in the first half. Yep. Because of lack of traction. I'm on traction control in through fourth gear. So it's not like destroying at traction control. It's just like right on the edge of 5 to 8%, 10%. It'll hit 10% in certain areas. So it's really all about traction. And that's why all-wheel drive cars always go the fastest in a half mile, because they have way more traction than a front-wheel drive or a rear-wheel drive car.
Yep.
So I would say you have to have a fast street car to go fast. And by fast street car, I mean on the street, it's fast on like your normal roadway to go fast.
I just want to come back a little bit and dive into a term you used, which a lot of people may not have picked up. You talked about a soft 1,300 horsepower versus I think you called it a hard 1,300 horsepower. Now, a lot of people might be thinking to themselves, well, 1,300 horsepower is 1,300 horsepower.
Yeah.
But it isn't. So talk us through exactly what you meant by that in a bit more detail and how that affects the reliability of the engine parts.
Yeah. So I guess, we could, a soft 1,300 horsepower would be like, I'm ramping the boost in as RPM goes.
Yep.
So it's, let's say at 6,000 RPM, it's 20 pounds, and at 7,000 RPM, it's 25, and 8, it's 30, 35. So it's like a straight line.
Mm-hmm.
We made the joke, called the Honda power band, because Honda's, if you're trying to make a car hook on the street, you can't have a Evo power band that can put everything down. You have to have a soft power band, or a flat torque curve, essentially, is what it ends up being, because as RPM goes up, the power keeps going and your torque kind of maintains. And so that helps keep the tires from spinning, right? Obviously, you can get into all the other torque control and all this other stuff, but in reality, it just comes down to controlling the tire and how much the tire can do at a given speed and road, etc. So you're always fighting a traction control issue on a front-wheel drive car.
Yep.
And so the soft 1,300 it's 1,300 at 10,500, right? And when my 1,300 in the all-wheel drive car now, it's peak power at 8,500, and it holds it till just about 10,000, and it's got a big meaty power band.
You're not ramping that boost in soft. You basically want to hold that wastegate closed as long as you can, get full boost as soon in the rev range as the turbo's able, and then hold it.
You want the biggest power band you can get.
Yeah. Now, I think this really sort of feeds into another thing about sort of engine building, engine reliability, and what you can expect from the engine. It's not really necessarily the power in and of itself that the engine has to support, but it's cylinder pressure, which is actually more to do with the torque curve. So we're going to have maximum cylinder pressure at peak torque. So what you're saying there, by having that soft power curve, ramping the boost in slowly, what it does is artificially lower the peak torque value, because you don't have that big sort of bulge in your torque curve and it drops away. You're sort of holding, as you said, that flat torque curve. So less cylinder pressure, easier on the engine components.
I would say easier on the everything, engine, drivetrain, whatever you want to call it. It's easier on all of it because it's less torque sooner. So, when I'll send you the picture of what my dyno sheet looks like now versus what it looked like when it made like 1300. It's pretty scary how much different it is. I mean, we're talking, it's like 250 foot-pounds, 300 horsepower at like 7,000 RPMs higher now than it was.
It's not insignificant.
So I hit the car a lot harder when I started drag racing it with a good tire because I couldn't hit it like that on a 245, 45, 16 Toyo R888, right? When it was front wheel drive. So, I'd say the harder you hit it, the more power or torque sooner you hit it, the more hard like you said, peak cylinder pressure is going to be harder. You're going to hit everything harder, components of all sorts.
When you were talking, staying with this description of soft versus hard power, and you said, like particularly in a front wheel drive, you weren't really able to use a hard power strategy because you'd just be lighting the wheels up anyway.
Correct.
What does this mean in terms of traction control differences? Like, why is it that you couldn't make use of effective traction control strategies with a hard tune or a hard style engine versus a soft? Obviously, there's a reason. So, what are some of the intricacies there?
It's too much power for what you have, essentially. So you're always fighting traction. Go ahead.
I think probably what we're always trying to do here, and this really goes for drag racing, or at least it was my philosophy as well as circuit racing, is we don't want to be relying, like riding that traction control all of the time. And particularly in very high horsepower cars, it actually can be potentially damaging to the engine. We talked to the guys from Proline, for example, and they want to make sure that they're not having any cuts occur because it can damage components quite quickly.
So that's an interesting, because I've always we'll circle back on that.
Let's come back to that. So basically what we want to try and do is taper or tailor the torque delivery of the engine to the amount of traction we've got available. And then we're just kind of using that traction control in the background as a bit of a safety backstop in case we get it a bit wrong, because we're always pushing the limits, right, Myles? So, run by run, we're always tweaking boost curves and power levels so that we're trying to optimize the amount of traction that the track gives. And that also develops over a race weekend as well. But sometimes we might overstep the mark, and that's when we've got that traction control just to make sure that we're not going to end up facing the start line.
So, but even without the reliability perspective there of being hard on engine components, you're saying it's still, from a performance perspective, you're still better off not relying on those electronics.
Well, there's an argument for that, which is interesting because we know obviously there's a lot into this depending on the specifics of the tire. You will get maximum acceleration with a small amount of slip.
A little bit of correct.
So technically, some traction control intervention, Myles, you're talking 6 or 8%.
So obviously, for me, it varies per gear because 10% at 180 miles an hour is different than 10% at 100. So my car will do 10% in second and third, and third will go to 130 miles an hour, and then fourth and fifth will drop to like 7% and then 6% in fifth, to try and keep that number as close to as I can be. So for example, just recently, I took my car to the drag strip and I destroyed the transfer case hypoid gears, and I was a little frustrated, and I did what I tell no customer to do and stayed in it the entire time. I knew as soon as I shifted into second that I broke it because the car sounded like it was pissed off, like so bad. I was so hard on the traction control. My RPM trace looks like an EKG, right? That's how bad it looks. And I'll send you that picture too if you want to laugh. And I was like, this doesn't sound good. Something's going to hurt this thing.
This doesn't sound good. Let's stay in it.
Let's stay. Yeah, well, pretty much. Yeah. It's still trapped 160, but it was so far off. It was so against the traction control that it was not healthy for the engine.
That slip target number you were talking on the tires there, you were talking something.
Yeah.
What was it? 8-ish% in the lower gears and moving down to 5 or 6 in the higher gears. Is that coming more from sort of experiment? Do you guys have some tire data on this? Are you just sort of trying what works? You try different slip ratios and you just see where you're getting the most drive?
So initially when I first did it, I didn't have maybe the data that I have now. I didn't have an IMU or a GPS. I just had like what felt seat of the pants. And at the time it was half mile racing that I was doing when I first switched to the Motec and stuff. So to me, I talked to some people and everyone always said 10% was a good number. And so I just kind of started at 10% and I felt like I went down to 5% and it definitely didn't accelerate as fast. It didn't feel the same. I went to 8 and I was like, oh, this feels good. I went to 10. I'm like, oh, this feels real good. And then being it's a front wheel drive car, you don't have to worry about the tail sliding around, right? So I've heard some rear wheel drive cars at 12 to 15%, they're getting really hairy and they're not going any faster. So I feel like the number I came up with after talking to people and also doing that, 10% was a good start. And I would say anything between 10 and 12 miles an hour of slip is about what I thought felt the best to me. And this was, again, when I started back in the day without any real data that I have now. So I would say it was a little bit from listening to what John Reed said. He's like, 10% is a good starting point. And then I would also say the tire you're on might like more slip or less slip and depending on where you're at too. So it kind of varies, but I would say on a Toyo, I've noticed 10% or 10 to 12 miles an hour different at most seems to be a pretty quick, the quickest I would say on not a drag strip on the street.
Yeah. And that's something I was interested in as well, is how much does that target slip change going between different tire brands or maybe tire pressures or different wheel alignment settings or whatever you might be using. I don't know if you play around with that stuff much, but does that target slip change if you go to a different brand tire much, or you find you more or less in the ballpark?
I would say if you go to a different tire, like let's say an M&H bias ply slick, that's not a slick, but it's a bias ply street tire, that slip percentage is going to want to be more. And I just think the tire wants to slip more because of how it is.
There's a difference between a bias ply and a radial construction.
Exactly. So I would say those want more slip.
Sure.
But those are not as stable at 200 miles an hour as like a hard R comp. And I've been running a Toyo for 5 or 6 years, and I feel like for the size that they work really, really good. Really, really good. I would say Toyo doesn't want anything to do with it because I think I'm like 50 miles over the rated speed that I'm going. But I think my tire size is good to 165, and we're not going that fast. We're going quite a bit faster. So call me dumb or questionable, whatever you want to do. So I've been running that tire. So I ran a Toyo R88 first. Then I went to R88R. I talked to one of the Toyo guys that I met at a NASA road race at actually 25-hour Thunder Hill. And I saw him every year at PRI. So I was like, hey, like, what's the new cool tire? And he's like, oh, we got the new R88R. He says, shows me this little sheet and it says, well, it's good for about 3% more slip, or it's 3% better than the old Toyo, and I think that's just the design. There's more tire touching the ground. So I started using that and I'm like, oh, this thing is a little better. Then they came out with the Toyo RR, which is a DOT race slick, and it's got 2 grooves down the center.
Sure.
And I tested that tire back to back at TX2K one year, and the same power, the Toyo R88R slipped 4% more on the same track with the same power, with the same everything. So to me, it was the RR was worth more power. I could put down more power, right?
Sure.
Less slip.
Yep.
So it means I could give it more power sooner. And so I started using those, and I think Underground Racing uses that same tire now. I talked to them. I'm like, you should try this RR, this Toyo RR. So I'm not going to say I'm a direct salesman for Toyo, but I've spent a lot of time that I feel like for what my car has done to be on the tire that it is. I mean, it went 213 on a 245, just two tires,
Yeah,
245.
that's pretty impressive.
Yeah.
Do you think
Yeah.
that underground racing need any more advantages, though? Let's be honest.
They still need more traction. It sounds like they still need to figure out how to, because if you listen to those cars, they're still spinning in fifth gear, sixth gear, and it's like, listening to them. And if you watch them from behind too, they get every shift the fuel gets darker and darker and darker, richer. I mean, I don't know what fuel they're not on ethanol or straight methanol. I'm pretty sure they're on race gas.
Sure.
For a lot of the, or some sort of mix of some sort. So yeah, they had to learn, they had to get there the hard way too. So.
Definitely. We all do. Yeah. Let's come back a little bit to my favorite topic of head gaskets, and we'll actually sort of talk about head gaskets and sleeving, because this is something that we had the advantage with the 4G63 that it was a cast iron block. So while it's not bulletproof, and these days there's billet options for the 4G63 as well, but definitely in comparison to mainstream alloy blocks, there's not too many 4-cylinder alloy blocks that you'll punch 1200 wheel without needing to do a lot of work, and we certainly could with the 4G63. So
you could,
talk us through what have you done to the B18C in terms of sleeving for a start, and then we'll get onto the head gasket.
Yeah, so right now it has Darton sleeves. I
guess start by, for those who aren't even aware of what that term sleeve is, what is it? Yeah. What does it do? What does it replace, and why do we need it?
It essentially replaces the entire cylinder wall. It's a reinforced cylinder wall. So factory, they have like a little, I'll call it sleeve with probably, I think it's like maybe a 1/4 inch, or no, like probably 1/8 inch of steel, and then aluminum on the outside. And the sleeve it's an open deck. So nothing's holding the sleeves from moving around at any time. Factory in 94, when my car came out, they're like, oh, it's a 185 horsepower car. No one's ever going to try to make more power with these. So
little did Honda know
that I wonder what the Honda engineers think, 20 years, 30 years ago, what they were doing, what they're doing now. Like, are they like, yeah, we designed that stuff? Or now it's like, what are they doing? So, so you're replacing the cylinders, essentially the cylinder sleeves completely. So when they put these Darton sleeves in, they literally cut out all the factory sleeves almost. I don't know the exact process, so don't quote me on that, but they cut most of it out, and then they press the sleeves in. And these sleeves are significantly thicker, better. I think they're iron. I couldn't tell you the exact combination.
Ductile iron typically.
Ductile iron, yeah. And these are still a wet sleeve, which means water still goes around them and goes up through the cylinder.
Yep.
And when on like your 4G63 back in the day, did you do a cement filled, or did you have water run through it still?
We did both, but for my own car, which is probably the one we pushed the furthest, that was fully cement filled, grout filled right up to the deck surface. And we did run water through the cylinder head just for some cooling, but you can get away with a lot of evils when you're running on methanol fuel with the cooling properties of that. But more problematic if you running on gasoline-based fuels, and definitely if you want to take it to the supermarket, it's probably not going to work that well for you.
Yeah. So
Starbucks.
Yeah, Starbucks, supermarket, Chipotle. I mean, I've got pictures of it pretty much everywhere. It's funny as it sounds. So, it used to be a daily driver a long time ago. It's far from that. It's actually sitting in the shop right now because it's broken. So
of course it is. We'll get on to that. So
get onto that. Yeah.
The other thing, you've sort of explained it, but just for those who aren't aware, so it's not just the sleeve. As you said, in stock form, the B18C is an open deck block, so the sleeves are not connected to the outside of the block, and that's fine with stock power. But when you get really high cylinder pressures, first of all, those are going to start moving around, which results in problems with head gasket integrity and leaking, but also in extreme circumstances, you can end up actually cracking the factory liners. So these Darton sleeves replace the factory liners. Much thicker, stronger material, ductile iron, but they also have this flange on the top, which actually basically locates against the outside of the block as well. So that's really sort of positively located, and we don't have this problem with them walking around under high cylinder pressure anymore.
Well, they still walk. Well, I found out they still walk around, but up to a certain power level, of course. Obviously, I used to just have a step deck block. Probably, I think it was 2,500 to 3,000 step decks. So the sleeve was protruded 2.5 to 3 thousandths above the rest of the block.
Yep.
So when you put a head gasket on it, it's clamping down on that first, sealing the cylinder from the coolant. Obviously, it's still water. Water goes through the block, goes through the block and goes through the head. So
yep.
Up to a certain power level, I believe it was somewhere around the 1100 horsepower range, 1120 or something. All I had was a step deck block. And then once I got to that power level, I started pushing gaskets, and we knew it would come eventually. So then I went to an O-ring cylinder head. So we took a stainless steel O-ring, cut a groove in there, 41 thou wire, and it protrudes, I think it was somewhere around 5 to 6 thousandths out of the head. And then it's still used an MLS gasket. And if you talk to Cometic or any MLS gasket maker, they'll tell you, oh, you can't do an O-ring with these. Like, they won't work.
We've had exactly the same situation. People telling us that won't work, but we ran the same. We actually did it the other way around, which
you did in the block.
We did it in the block, which I kind of regret. And I think I was around 6 thou protrusion, same deal, 41 thou stainless wire, and that was into an HKS stopper type head gasket. And that took us, up to, we were still running that at 1200 wheel. So and that'll take you so far. But there's a variety of other techniques. I mean, you see what Top Fuel, Top Alcohol do. That's the stainless wire O-ring in the head, more protrusion, copper gasket that'll deform, and then a receiver groove that the copper gasket gets deformed into in the block or the top of the sleeve. Out of interest, did you ever try that technique?
Not on this car. We do that for the 4G63 stuff.
Okay.
But I never did because we run water through mine. So it was one of those things. So I went from that to the O-ring. And then after the O-ring, I got to pretty much last year. I hadn't had any head gasket problems up to 1300 horsepower, roughly, 55, 60 pounds boost. I never had any problem. Then I started drag racing it, hitting the car sooner or earlier with a lot of power in second, third gear that I never would hit it before since I was, traction limited. Then I started seeing coolant pressures go up and higher. So then we did the fire ring, and I did the fire ring a little different, mainly because I already had the O-ring groove cut in the head. So I had a fire ring made for the exact size of the O-ring that I had cut in the head. And so then I put the fire ring in the head and put it on the block. Okay.
It's just for those who aren't aware, and I mean, there's a lot of terminology which people sort of mix and match. So when you're using that term fire ring, what specifically are you talking about?
It is like I think it's a copper beryllium, some sort of ring that has a little leg that locates in either the sleeve or the head. And then I think the numbers are between 2 to 3 to maybe 4 thousandths protrusion over whatever your gasket is. So it's just a metal on metal, metal on metal. What's the word I want to use? Seal. Yeah. Metal on metal seal for the combustion cylinder. So it's basically, you're clamping, you're torquing this head to 100 foot-pounds, and you're putting this little fire ring in there and clamping it down. And so you hope that nothing gets through that, because you're like, well, if something gets through this, then there obviously has to be some serious cylinder pressure going on. And
I think that's a technique I've had a limited amount of experience with. It sort of became the norm pretty much after I'd retired my car. We did it on a couple of customer cars. I think I could be wrong. I think the material is actually an aluminium bronze alloy.
Yes, it is. I think I had a ring that we had tested. This is another version of one here too that IAG uses. This one looks similar, but this doesn't have the leg on it. This is actually machined right into the sleeve and sits into the inside, and the piston goes up on there. So it's a different style.
Yeah, what's the purpose of that leg that you were talking about to locate it? It stops it rotating, or what is this?
I think it's an easy way to keep it in there. I think it adds support, but I mean, Andre probably has a better
I think you're pretty much spot on there. Just positively located. I mean, again, that you've got all of that cylinder pressure trying to force the thing out. There's a variety of techniques. I know there's a gasket company that basically do the same sort of thing now, where it's just located physically by the gasket. So there's no one size fits all answer here.
Those suck to a certain power level. They work, but they're not as good as I think locating it in, because I've seen them literally blow out right there, and I think the crush in it's pretty small too. I think it's an Athena gasket, actually. They have three little small points.
They do, yes.
And those dig into the head, and they work pretty good. Just once you get to the big power stuff, they're not quite as good.
I think it's probably also worth mentioning that those aluminium bronze sealing rings, or fire rings as you've called them, I'm pretty confident as well. Those are being used in the majority of the Pro Mod turbo drag engines as well. So it's a very proven technology, and some of those are definitely 4,000 plus horsepower. I forget now. They're huge numbers.
I mean, definitely. I think they're being using it a lot. They're not using them in top alcohol, top funny car though.
No,
they're still using the old school. They don't want to change anything.
If it isn't broken, don't fix it.
Well, they replace everything every pass anyway, so to them it's easy to do that. And so I think a lot of the newer technology stuff is definitely more let's call it fire ring combo for sure.
I think the other thing that needs to be considered is like some of these small capacity import engines. We've talked about you're making 1,400 wheel, the GTR's 2.5, maybe 3,000 wheel from 4.1 liters or whatever they might be. But the specific power levels are incredibly high. And it's
and per cylinder too.
Yeah, and the combustion pressure again is what we're fighting against here. So you sort of have to keep it in perspective. We talk about some of these Pro Mod engines, we've got a lot more capacity, obviously more cylinders as well. With the sleeving as well, I know that we go through the sleeving process because we're trying to fix this problem with the liner strength. We're trying to stop the things moving around and improve the head gasket integrity. Yet here in New Zealand and people I talk to all around the world, it's so prevalent that they go through that process, which is expensive and time consuming, and then get the engine up and running. And we go through this problem of what's referred to as the sleeves dropping, which is where they might move down after everything's heat cycled. They might drop by 2 or 3 thousandths of an inch. And then, of course, the head gasket leaks.
That's all you need.
Which is then kind of creating one of the problems we're trying to fix. Now you can get around that, pull everything apart and redeck the block. And generally once the sleeve is moved once, it kind of seems to stay put. So you're good to go. But obviously that creates a second rebuild, a huge amount of time and expense. So how are you getting around this? Obviously you've sleeved your own block, and through English Racing, you're sleeving 4B11. So what's the secret sauce here in getting a one and done approach to sleeving?
I don't necessarily think there's a secret sauce. I think it's leave the sleeving to the machine shops or the manufacturers that do sleeving for a living, the guys who design the sleeves to be used. So, we use Darton sleeves and Darton East or AR Fabrication Howard. So he's been sleeving blocks for who knows how long, and he knows how to sleeve a block correctly. Now, I don't know what a lot of these people are doing. Maybe the press is not enough, and as an engine warms up, the clearances open up a little and that sleeve drops, I know we had an issue with a GTR billet block that we got at one point that the sleeves were installed incorrectly from what I remember hearing. And Howard said pretty much you put that block in at 150 degrees Fahrenheit, and the sleeves literally, you just pull them right out. They had very little press in them. And so we always felt like a step deck sleeve is the way to go. If it's a flat deck sleeve, it's never going to hold, at least with a wet block, it's never going to hold. And so we're always, 2 to 3 thousandths in a step. And then I don't know what the parameters are for installing the sleeves. If they're with a press, how much press they have. I don't know those aspects, but I've always been, don't just buy your sleeves on eBay and go to your mom and pop machine shop down the road and say, hey, can you install these sleeves for me? Because I would say 95% of the time it's going to be done incorrectly.
I do remember, I think it was a Do It for a Living podcast that Howard from AR Fab was on, and there was a bit of a conversation about that. And I seem to recall at the time he's using the best of the best gear. It's all CNC boring equipment, which obviously makes sense when you're working to those tolerances. And I'm not a machinist. I do remember talking to the machinist we used to use through my old shop, and had done a few sleeving jobs and had had mixed success. Manual boring equipment, which obviously requires a lot more skill from the machinist. Not to say you can't get the results, but yeah. The point he raised, which I hadn't really thought about, is you're removing so much material from the block and its alloy with a high thermal expansion coefficient. And physically machining out all of that material creates a huge amount of heat. So the block itself during the boring process is actually going to change its dimensions. So I don't know. Maybe there's something in that. But again, I'm not a machinist and I definitely don't install sleeves. But public service announcement, if you're getting your block sleeve, make sure
to the guys who know.
Make sure you're using someone who's got some runs on the board, and it's probably going to save you from sort of problems further down the track.
Exactly. Yeah, I would say so. I would agree. I mean, I've had, I don't think I've personally ever had an issue with any sleeves. I mean, I've gone from a Golden Eagle to a Darton sleeve, and I've never had any issues with Golden Eagle. I do always hear people talk about, like you were saying, with once your engine's together and it goes through a first heat cycle, normally the sleeves settle a little bit, probably a half a thousandth is kind of the number that we see when we put it back together. Or when we take it apart, we see that. And if like you said, I don't know what it is in the clearance that they do or how they do it exactly, but like you pay the right people to do it and just let them do it.
I think that's probably advice that could be applied to a lot in the motorsport industry, to be fair.
Yeah, exactly. For sure. Definitely.
One of the questions I've had in my mind for a little bit here is about the difference between a B series and a K series. In the Honda world, you hear, K series is the rage. It seems to be what everyone is using for everything. So what is it about a B series that maybe makes it a bit more suitable for this application? Is this about because what you've got more experience with, or is there actually something different in the inherent design of the engine that makes it more suitable for what you're doing?
Yeah, I mean, the K and the B in different aspects. I mean, the B series came as a 1.8 liter dual overhead cam and a very, VTEC that, when the K series, they come as a 2 liter and a 2.4 liter. So they're already a bigger motor. They're at probably 10 to 15 years newer technology. So you're already dealing with a bigger motor. You're already dealing with newer technology. You're dealing with a gear driven oil pump on the bottom versus like the one I have is like a gear inside of the crank. So you're dealing with a lot newer technology. And so in an all motor application and in just, I'd say even the same turbo application, to a certain extent, the K is a better motor. I mean, there's no doubt. Like people are making 700, 800 horsepower naturally aspirated now in K series motors with nitro on top, and we're talking like 2.5 liter, 2.7 liter motors making 700 horsepower on a dyno. I mean, that's crazy, unheard of. So I would say the K is a more efficient motor when it comes to making the power naturally aspirated. To this day, though, the fastest sport front-wheel drive cars, which are all around specific rules, 2,400 or 2,450 weight, pounds, and then they're limited to a 7285. And
you're talking turbo there, just to
turbo, yep, 72 millimeter inducer, and I think 85, or I think they have a 106 or some. I don't know the exact numbers of how big they can go, but they're turbo limited, and all of the turbo limited classes, the B series cars are still faster. And I couldn't necessarily tell you why, because I've never had a K. My car came with the B series, and I kind of started with the B, and I'm going to end with the B. It sounds like as much money as I've thrown at it now. I was, if I did a K series, my all-wheel drive would have been a lot easier and probably not as expensive because the transfer cases are a little bigger on the K series stuff. So everything about them, they make more power easier. But when it comes to the very end of the limit, make the most power for the turbo you have, I maybe it's just the B series game's been around a lot longer and that combo is more perfected. But I don't think there are any 7-second front wheel drive K series SFWD cars yet. And there's at least 8 to 10 B series.
It's interesting. I've never tuned a B series or a K series that's anywhere near that power level, but I mean, in the naturally aspirated stuff and the mild turbo stuff, I mean, everything I have seen so far, pound for pound of boost,
destroys it.
Absolutely. So it's interesting that kind of doesn't hold to the 1400 plus wheel horsepower, but I mean, the proof's out there. So yeah, it'd be interesting to know a little bit more.
It's kind of like the Evo 10, at low power, the 4B11 at low power, same turbo, it destroys a 4G63 in my eyes. You stock motor, put the right turbo on it, you're making 450, 500 horsepower without opening or touching the entire motor. When on a 4G63, you got to do camshafts to be able to, a Evo 8 versus Evo 9. If you do an Evo 8, the cams are smaller than an Evo 9. So you struggle to make the power easier as in a 4B11. And now we get to the big power stuff, and the 4G63 still makes more power on our dyno and goes faster than the 4B11 does. But the power band the Evo 10 has is like retarded compared to the 4G63. We're talking Luke had a dyno pull we literally pulled wastegate line 100% duty cycle. It made 85 pounds of boost at 5,400 RPMs. And the same turbo, the same fuel, the same pretty much gear ratio on our drag Evo 8, it made 19 pounds of boost at that same RPM.
Yeah, that sounds probably a bit more realistic with what I'd expect.
Yeah. So, I would say maybe the power band and it just maybe it consumes the turbo sooner, I guess is the easiest way to say it. It throws everything at it as soon as possible and it gets there quick, but it doesn't have the very top end,
Sure.
Is kind of the only way. I don't have enough experience with the K series. The guys I talk to say they need 10 millimeters more turbo to go just as fast.
Yeah,
with the
it's
same.
interesting.
So, yeah.
Right. Let's just talk a little bit. You've alluded to it a bunch of times now, but one of the changes you've made this year, I think it's this year, is the four-wheel drive conversion. And I mean, you're definitely not the first to do this in the Honda drag racing world. But can you talk us through just real brief view of like what parts? Because using OE parts for this, what do you need to actually do a four-wheel drive conversion?
Yeah, so being my car's a B series, you have to go back to like the only all-wheel drive B series cars that were ever made were, Honda CRVs. So 97 to 2001, they came with a B20, and they came with the way they would work is the minute the front would slip, the front tires would slip, it would like activate an oil pump, I believe, that would then send power to the rear. So that factory didn't have a viscous or anything. It has... I think it has a little oil pump. I wish I knew more about how the CRV works, but essentially it was the only car that you could buy that was a B series that had a transfer case hung on and a rear diff and a driveline. So my car is a B series, so it uses a 99 CRV transfer case, and then I've got an 89 Civic Wagavan rear differential in it, which seems to be the strongest differential so far, even out of we're talking a 30 something year old car, and the parts, if you can find them, are seeming to be the most robust.
And obviously all of these parts came off Honda's showroom floor in 1400 wheel horsepower applications, right? So they're rated for the power you're making.
Yeah.
Okay.
So
good.
they're definitely not rated for that amount, but so, and then I have a 89 Civic viscous coupler in the middle. So I have a transfer case, then I have a drive shaft shop 2-piece carbon drive line, and then there's a viscous right in the middle right now it has 60K fluid in it, is what they call it. It's like a silicone fluid, and the thicker the fluid, the more power, or the less slip you have in the viscous. The thinner the fluid, the more slip you have.
Okay.
It has a 5-speed dog box in it, which I've got the first 5-speed dog box. Right now, everyone else has only had a 4-speed. Well, of course, my half mile, I'm not gonna try and go 220 miles an hour with 4 gears. I want 5 gears, right?
Yep.
So it's a custom 5-speed dog box. And then Speed Factory Racing did these billet bell housings because they were the first to do a big power B series all-wheel drive car in Ostrom 4-door Civic, which I think so far has been like 770 and 190.
Okay.
and I don't know what power he makes, but he says I'm his son compared to him as far as power. So,
Yeah, okay.
so I kind of copied all the stuff they did to an extent. Obviously, I went with a different manufacturer on the transmission, and the same with the transfer gear. So I guess the way to obviously on Evos you have a center diff that kind of helps front to rear power. Well, the easiest way I can explain this is it's direct drive with the viscous in the middle, and the viscous is what determines the power that goes to the rear.
Okay. Now, is this a problem in terms of how much power you can put through to the rear? I mean, the likes of Pronto Racing that we've interviewed, where they're drag racing these four-wheel drive Hondas, they're really setting the cars up still like a front-wheel drive drag car.
Correct.
And from my understanding, I can't remember if the number is exactly right, but I think we're talking something like 30% torque to the rear. And so it's only really a little bit of power going to the back. So what's your what have you found so far?
Yeah, so I kept hearing this 20 or 30% number, and I was like, well, how could it be 30? Is it 30% at 500 horsepower? Is it 30% at 1,000 or 15? Because if it's a set percentage, the more power you make, that number is going to go up, right?
Mm-hmm.
So, of course, with the fluid that I had and with the dyno that we have, I'm like, well, I want to know exactly how much power this thing's actually making. So we unlinked the dyno. So front and rear dyno rollers are unlinked, so they accelerate disproportional to each other. So one can accelerate faster than the other. So we put it on the dyno, tried to make as close to 1,000 horsepower as I could, and it made 975, and it made about 50% front to rear power.
Okay.
And I only made 975, and the rear made, I think, 520, and the front made 508.
Okay.
And it slipped the tires a little in the front, didn't strap it down because I don't think we expected it to make the power it did to the rear. So when I put it on the dyno and we made this 500 horsepower, and I think it was 320 foot-pounds of torque, I'm like, this is way too much power. Like, there's no wonder these people are breaking these things. So at that point right then and there, I knew that with that fluid on the dyno, it was more than 30% power to the rear. I mean, at that point, we came up with just about 50%. And you can see the rear wheel speed was slower. So it wasn't like the ramp, the torque curve was more smooth to the rear, or the power number was more smooth, but actually put more power to the rear than the front on the dyno. And I think that's just because it just spun the tires a little more in the front. I didn't strap it down as hard. So
is that a problem for you in terms of getting the car down the strip, or are you worried more about the strength of these low spec OE parts failing on you with too much power?
Yeah, so I mean, pretty much 7 launches in, I'm already broken my OEM parts on the car. So
at four-wheel drive life.
Correct. Yeah. So on an Evo, we have a transfer case with a ring and pinion that's like 7-8 inches wide, right? So your power is going through that. Well, on the Honda, I mean, it's that the gear that it's putting there's 2 gears about this big that's putting all that power to the rear to the hypoid gear, they call it. And well, on the B series, those are smaller. And well, like I said, 7 launches, it broke that gear already. Now, in hindsight, I threw out, as my one coworker says, I threw the kitchen sink at it in the launch because I think it was like 50 pounds of boost in first gear that it ended up making. So it was like 1,200 something horsepower with the Motec set, and as soon as I shipped it second, it just went broke. And so it was too much power, but it still comes down to, we want to set the car up more like a front wheel drive car. I want to actually have the traction control do something. I want a little bit of push from the rear. I don't want an Evo power. I don't want an Evo 50/50 because we don't have Evo parts as far as power or big enough parts. So yeah, it's too much already. So
when you said the transfer case you're using in the center is CRV, the rear is an older Civic. What are you doing as far as treating these things before they go in? Is it literally a case of maybe giving it some fresh seals and some oil and sending it? Or, I mean, you taking these things apart and special surface treatments and clearances and blah, blah, blah. What are you doing to these things?
Yeah, so I forgot to mention I have a billet transfer case. So the case itself is billet, not OEM, because it sounds like it would have definitely broke really quick had I had not put that in. So the transfer case, the billet transfer case, seems to hold everything together a lot better. It's like a billet block. It's more rigid. It's got more it's just stronger in that aspect. So that's OEM, or that's not OEM. Those hypoid gears, which basically sends the power to the rear, those are the only OEM parts in there. There's a transfer gear that has I could have brought those parts in here, showed them all, because they're just sitting on the shelf right now. So those things, they have a transfer gear that rides off the differential in the transmission. So that sends the power. It's like direct drive right off of the transmission differential itself. And so that is an aftermarket piece too. You'd pretty much break that right away. So I now have a PPG transfer gear that's going in the car because I broke the other one already.
Yeah.
And the other aftermarket one. The rear differential is pretty much OEM ring and pinion. It's pretty crazy. It's pretty small. I compared it next to a GTR, like an R35 front differential ring and pinion, damn near the same size actually. Okay. So, and we've seen 600 horsepower to the front on one of those before. If you do upgraded clutches and dyno it like I just did. So it's pretty big. And then I put a limited slip in the rear. So it has a limited slip in the rear instead of a factory open diff.
Yeah, makes sense.
So it pushes normal. And when you start to turn, you can kind of feel that it's got a little more drag in it than it would as a front wheel drive car. Yeah. But other than that, the ring and pinion are factory, and those hypoid gears are the two factory components that I feel like are going to be the next breaking point. Well, I've already broke the one part, so.
Well, look, Myles, I think we could probably spend another hour chatting to you, and maybe we'll come back and revisit this another time. But for now, I think we want to respect your time and probably move towards wrapping this up. And one more point on the Integra. Obviously, this four-wheel drive thing is a relatively new development. You said you've gone 213 on the half so far. What sort of end game do you see? Where's the limit? Where do you expect to be once you've got this four-wheel drive set up, dialed in? You can feed it some more power. Where do you see yourself going? You mentioned 220. Is that sort of the target for now?
I think 220 was one of the goals. Really, 225 is that goal right now. As crazy as it sounds, that's kind of my dream, to go 225 in the half mile and I think 180 in the quarter unprepped. So 225 is my 225 is my current goal, and I am going to a half mile event in about 3 weeks. So we'll see if I break something again, or if who knows what's going to happen there. I'm hoping that it goes faster than 213, but obviously it's so new. I think I pulled the tranny out of this thing 8 times already this year, so it's pretty new, and it's a bit of a I'm not losing motivation, but I'd rather be on the jet ski than work on my car most of the time these days. So
I do remember that it gets pretty disillusioning when you're spending more time hanging on the end of a spanner than you are driving the car down the drag strip. And the old saying goes, we spend more and more money on our cars to spend less and less time in the driver's seat, which is sadly true. Doesn't make a lot of sense, but unfortunately that drag racing bug bites pretty hard as well.
Yeah.
One of the questions we like to ask our guests is, looking back at your career so far, if you were to give advice to someone, a younger version of yourself looking to get to where you have in the performance industry, what would be your advice? What should they be doing?
Oh, man. I would probably, the one thing that I didn't do that I should have done is I should have just did a sleeved motor since day one.
Okay.
I went through stock sleeve motor, I went through so many different variations that if I'd have just spent the money and done the motor right the first time, I probably would have saved myself about 3 motors. And so if it was me, just spend the money up front to do the motor correctly. Because once you've got the motor done, because everyone's like, oh, I got a fully built motor, but I got stock sleeves. Well, that's useless,
I think you're basically describing your worst nightmare customer.
Yeah.
You were that guy.
I added up the other day how much it would cost to duplicate the Integra to the T. It's pretty sad. It's
never add it up is my advice.
If someone wanted to duplicate the car how it sat right now, it'd be $100,000 in just parts. It's pretty sad.
Yeah, I think that's the other aspect. That coming back to that question I asked a while back.
Are you ready to spend the money?
Well, yeah, that's sort of, we see these big numbers being thrown around on the internet. It's not just the reliability, which I also mentioned, but people don't actually really have an appreciation for exactly what it's going to cost to get your car to that point with some level of reliability.
Correct. Yes. Yeah. I mean, you can make the power once and you can put a different ECU and you could do a lot of stuff, but to duplicate something that's proven and works, and I could pretty much duplicate a car for someone and tell them it'll make this power and it'll survive down the track at least one day. It's a big amount of money that most people aren't ready for. So, yeah.
If people want to follow you and see what you're up to, what's the best place to see what you're doing on the socials?
Yeah, I would say the easiest place is Instagram, which is at Gringo, Gringo, Tegra, Tegra. I grew up in the Dominican Republic, and I was called Gringo. Of course, when you grow up in another country and you're the minority, they figure out a name to call you, and Gringo was the name. And I had an Integra, so Gringotegra just kind of worked, and it's sat since there. So that's the easiest place is Instagram.
And English Racing, anyway, we can see what's going on there.
Yeah, same thing, English _racing on Instagram and also Facebook. And then obviously Myles Kerr on Facebook, which is Myles, last name Kerr. You can follow me on there. I usually share the same amount on both of them. So
perfect. Oh, you might be inundated with new followers. You never know your luck.
Yeah.
Look, really
you
appreciate
guys have a good following.
Really appreciate your time today, Myles, and we wish you all the best. Striving for that 225 mile an hour half mile. Maybe we'll catch up after that and get a bit of a rundown on how it all went. So thanks again.
Yeah, I appreciate it, and I'll keep you up to date. Thank you for having me.
Cheers, Myles. Thank you.
All right. Nice to meet you.
All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.
Nice.
Got there in the end.